Lesson 12.5, Probability and Compound Events. Compound events. Write this definition down. Compound events are made up of two or more simple events. Compound events can be independent events, where the outcome of the first event does not affect the outcome of the second event. Or they can be dependent events, where the outcome of the first event does affect the outcome of the second event. And they can also be mutually exclusive events, where the two events cannot occur at the same time. Here are some formulas that you need to know. To find the probability of independent events. So the probability of event A and event B happening, if these are independent events, equals the probability of A times the probability of B. The probability of dependent events. So the probability of A and B happening is the probability of event A times the probability of B following A. And we'll go over some of those examples. If they are mutually exclusive events, the probability of A or B happening, you would take the probability of A plus the probability of B. And then if they're not mutually exclusive, and you have the probability of A or B happening, you find the probability of A plus the probability of B, and you subtract out the probability of A and B. Pause the video, get that all down in your notes, and let's go ahead and do some examples. Okay. A bag contains 6 black marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is selected, replaced, and a second marble is selected. So the two events are that you select the marble one time and you select the marble the second time. Those are the two events in this compound event. The first question you have to ask yourself is, are these independent of each other? Will one outcome affect the other or not? And the answer is, because the first marble that is selected, because it gets placed back in the bag, then these are independent. Really, whatever is selected first doesn't affect the second marble. Okay, so let's find, these are then independent events. So let's find the probability of you selecting first a black marble. So in total, we have 6 black, 9 blue, and 4 yellow. So that gives us a total of, did I forget something here? Oh yeah, and 2 green, and 2 green. So 6, 9, 4, and 2, that's a total of 21 marbles. Okay, so you need to know that in your bag, there are 21 marbles. So what is the probability of you selecting a black marble? That would be 6 out of 21. Because these are independent, I'm then going to multiply that times the probability of selecting a yellow marble, which is 4 out of 21. So when we multiply this, you have 24 over 441. And to write that as a percent, you would divide and write your decimal as a percent, 5.4%. Okay? Go ahead and try number 2 on your own. Pause the video, please. Okay, so for number 2, the probability of selecting blue and then selecting green would be 18 out of 441, or 4.1%. Okay, let's do number 3 together. The probability that the first marble is not black and the second marble is blue. Well, let's think about that. How many marbles are not black? Out of the 21 marbles, 15 are not black. Okay, and how many are blue? 9 out of 21 are blue. So we would go ahead and multiply and get 135 over 441. And as a percentage, it's 30.6%. Okay, let's continue. Cynthia randomly draws 3 cards from a standard deck, one at a time, without replacement. Now here's the key. The key is that every time she draws a card, she does not put it back into the deck. Okay? So these events are dependent. Why? Because every time she selects a card, she's changing the deck because she's not replacing the card. So these are dependent events. So let's go ahead and calculate the probability. Look at number 4. Probability of selecting a diamond, then a spade, and then a diamond. A diamond, and then a spade, or then a diamond, and then a diamond. Okay, so for the first event, what is the probability that you're going to select a diamond out of a standard deck of cards? Well, if you know anything about playing cards, there are 13 diamonds out of 52. 13 out of 52 are diamonds. Now remember, you selected a diamond and you didn't replace it. So now your deck is missing a diamond card and it's down 1 card, so it's only 51 cards. So then the second event would be selecting a spade. So how many spades are in the deck? There are 13 now out of 51. Okay, and then the third event, the diamond, there are now only 12 out of 50 cards. Okay, so let's go ahead and calculate what the probability would be. Okay, we have, after we reduce, 13 out of 850. 13 out of 850, and as a percentage, that would be 1.5% chance. Okay. All right. Number 5, try that one on your own. Pause the video. Okay, please check your answer. All right, let's continue. A die is being rolled. Okay? So, what is the probability that you will roll a 3 or a 5? A 3 or a 5. Well, this event, it's mutually exclusive. You can't roll a 3 and a 5 at the same time. So what you have to do is find the probability of rolling a 3, which is 1 out of 6, and add it to the probability of rolling a 5, which is 1 out of 6, and we would get 2 out of 6, which is 1/3. Okay, and this would be about 33%. Okay. Number 7. What is the probability that you will roll at least a 4? Well, let's think about it. At least a 4 means you can roll a 4, a 5, or a 6. To roll a 4, you have a 1/6 chance. A 5, is a 1 in 6 chance, and a 6 is a 1 in 6 chance. So when you add this, you have 3 over 6, or 1/2. You have a 50% chance of rolling at least a 4. Okay, let's move on. Of 240 girls, 176 are on the honor roll, 48 play sports, and 36 are on the honor roll and play sports. What is the probability that a randomly selected student plays sports or is on the honor roll? These events are not mutually exclusive. As you can see, there are some girls that are both on the honor roll and play sports at the same time. So these are not mutually exclusive. Let's figure this out. What is the probability that the student plays sports? Well, it's 48 out of 240. Then let's add the probability that they're on the honor roll. That's 176 out of 240. And now we need to subtract the ones that are counted twice. In other words, the ones that do both are in sports and on the honor roll, and that's 36 out of 240. And so when we reduce, the answer is 47 out of 60, or 78% probability. Okay? All right, that's all I have for you for today. In calculating probability, we will practice this quite a bit in class tomorrow. Go ahead and work on the assignment that's for homework, and we'll check that tomorrow as well. All right, good night. God bless you.